So let's get started here. So our objectives today are to multiply radical expressions, rationalize denominators, introduce imaginary numbers, simplify imaginary radical expressions, and simplify complex numbers. Okay, here we go. So I have a monomial times a binomial. So we're going to use our rules that we know of working with rational expressions, and we're going to take, and I'm going to help you out here. This is 1 square root of 2 times 6. So that becomes 6 square root of 2 plus, now these are both radicals, so square root of 2 times square root of 10 would become square root of 20. Everybody comfortable with that? But then we could look and see, can we break down the 20? And that's 4 times 5, and I'm going to circle the 5 because square root of 4 is 2. So now I have 6 square root of 2 plus 2 square root of 5. These are not like radicals, so I can't combine them. That's all I can do. Okay. So now I have a binomial times a binomial. First, outer, inner, last. Here we go. Square root of 3 times square root of 2 becomes the square root of 6. Good. Our outer would become what? Plus 7 square root 3. Our inner would become minus square root of 10. And our last would be 7 times negative square root of 5. How about negative 7 square root of 5? And all of these radicals, all these square roots are simplified. None of them are like. Would you all agree with that? So that's your answer. Circle it. So let's do this one. Now look, this is a binomial times binomial, but look how the difference. See how the exact same thing except 1 plus 1 minus, so we know what's going to happen to our outer and inner terms are going to cancel. What's the square root of 5 times the square root of 5y? Or, I'm sorry, I said it wrong. What's the square root of 5y times the square root of 5y? Seth?
5y.
5y. Because in our head we should know, wait a minute, square root of 5 is square root of 25. What's square root of 25? 5. And square root of y times square root of y is square root of y squared. What's the square root of y squared? Y. So if I ask you what's the square root of blah, blah, blah times the square root of blah, 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 it's going to equal blah, blah, blah without the square root, okay? So we know our outer and inner cancel, and 2 times negative 2 is negative 4. There we are. Questions? All right. Now, the example I just showed you, this is the conjugate of this. So this binomial is the conjugate of this binomial because it's the same thing except different signs. So that's what we mean by a conjugate. All right. We're gonna practice multiplying by conjugates here in a second, but before that, I want to look at this one. If I had the square root of 3 minus 7 quantity squared, if you need to, write it twice, but we could probably just go, okay, what's that first term? That first term squared, square root of 3 squared. Matthew, what would that be?
3.
3, nice. And then our outer and inner, we'd go this times 2. Dylan, that would give me what?
Negative 14 times the square root of 3.
Good. And then our last term would be what, Ms. Durbin?
49.
Positive or negative? Positive 49. Because negative 7 squared. And then we can do what, Cole?
Simplify. Add like terms.
Continue. Tell me, be more specific.
49 and 3.
Yeah, so add 39 or 49 plus 3, which gives me 52 minus 14 square root of 3. Let's do this. Let's write the rational number before the irrational number if we're simplifying through. Okay? I wouldn't count it wrong if you wrote negative 14 square root of 3 plus 52. But it's going to kind of get us to the complex numbers, we'll write the real before the imaginary. Okay? So, here we go. This is even though you're going, this isn't a binomial. Yes, it is. Look up here. That's a term plus another term. So here we go. So when I square this, think about what's the square root of x plus 1 squared. It becomes simply what, guys? X plus 1. And then this times 2 will give me what, Charlie? Plus 4 square root of x plus 1. And then plus 2 squared would give me plus 4. And then I could combine the 1 and the 4. So I would write it as 5 plus x plus 4 times the square root of x plus 1. We okay? All right. Okay, now I have a binomial times a trinomial. All right, let's take the cube root of 2x times the cube root of 4x squared. Okay, so I'll write it out. That would become the cube root of 8x cubed. I know you all could go straight to it right now, but we won't do that. So I'm just multiplying the first term through. So then it would be plus the cube root of 4x squared plus 9 cube root of 2x. Everybody comfortable with that? And then we're going to distribute the negative 3 through. So that would be negative 3 cube root of 4x squared. I'm going to write it like right below like terms. It makes it easier to combine them. And then negative 3 times the cube root of 2x squared would be negative 3 cube root of 2x. And then minus 27. Did I do that right? And see how we lined up like terms? So then, question, guys, be careful right here. Come to this. What's the cube root of 8? 2x minus 2, because 1 minus 3, so minus 2 cube root 4x squared plus 6 cube root 2x minus 27. And I just said have the rationals before the irrationals. For this one, since it's so many terms, just put it in the order that it came out to be. I'm okay with that. We still okay?
Yeah.
Good. All right, so here we go, the rationalizing denominator. So look at this one. I can't have, so if we're going to simplify, we can't have radicals in denominator. So we're going to rationalize it. In this case, I'm going to multiply both the numerator and the denominator by the square root of 5. I'm not changing the problem because this is multiplying by 1. If I multiply anything by 1, it's still whatever it was. It's just I'm making it look different because what is the square root of 5 times the square root of 5, guys? 5, and then in the numerator, 2 square root of 5. I now have the exact same problem without a radical in the denominator. So that's called rationalizing the denominator. Okay? So be careful here. Guys, let's simplify before you start trying to rationalize. First of all, what's the square root of 16? 4 times 2 gives me 8 over 3 square root x. Because isn't the square root of 9 3 square root x? Y'all follow me? And then from here, Mr. Thornton, I'm going to rationalize the denominator by multiplying both numerator and denominator by the square root of x. In our numerator, obviously, we get 8 square root of x. And in our denominator, we get 3x. We okay? Okay. Now, Here we go. What's the cube root of 1? So let's get rid of that root in the numerator. It's 1 over, I don't know the cube root of 2. Okay, so it's cube root of 2. Who's got a game plan for me? What am I going to do? I'll let volunteers for this one. What am I going to multiply both the numerator and the denominator by? Taylor? Really? What's cube root of 2 times the cube root of 2? It's cube root 4. That doesn't help me. So Taylor, keep going.
I meant like, wait, when you just, would you multiply it by, never mind, I don't know.
Oh, come on, you're so close. You're so close.
Cube root of 4.
Cube root of 4. Nice. Because, think about it. Isn't 4 2 2's? And what's 2 of them plus another one becomes 3 of them. The cube root of 3 2's is what? 2. So you got to multiply both numerator and denominator by the cube root of 4. So 1 times cube root 4 is cube root 4. Over, Taylor, you get to redeem yourself. Over.
Cube root 4. Oh, never mind. I thought you were talking about.
Just quit talking and redeem yourself.
It'd
Be 2, wouldn't it? Because it gives you. We got it to be the cube root of 8, which we know is 2. Because there's 3 of them total. The cube root of 3 2's, boom, 2. Okay? Be here I have 1 over the cube, or it's not cube, the 4th root of 8. And that doesn't simplify. Okay? What am I going to do to rationalize it? Manachi?
Multiply both the sides by 4 is 2.
The 4th root of?
2.
Very good. Because, what is the 4th root of 8 times 2? The 4th root of? 16. What is the 4th root of 16?
2.
2. So I have 2 in the denominator, and I have the 4th root of 2 in the numerator. Starting to get the idea?
Yeah.
All right. So I have the 4th root of x over the 4th root of, wait a minute. Isn't 4th root of 81 3? Okay, and what, I could simplify that denominator. So let's write the 4th root of x in the numerator. But the 4th root of 81 is what? 3 and y, and then what? 4th root of y. So that's a good first step. Caden, we're not okay with radical in the denominator. So we're going to rationalize the denominator by multiplying both numerator and denominator by what?
You do it by square root of...
Well, first of all, we're talking about 4th roots.
Alright. The 4th root of... is this y?
Well, that would only give me 4th root of y squared, and that doesn't help me. Need to phone a friend?
Yeah.
Coin?
4th root of y cubed.
Good. Because think about it. I'm going to write it in both numerator and denominator, and then let's talk through it. What's the 4th root of y times the 4th root of y cubed? The 4th root of y to the 4th, which becomes y. So, Sam, what's my new denominator? Yeah, what's it become? What's the new simplified denominator? Well, Sam, what's 4th root of y times the 4th root of y cubed? What's this become right here when you multiply these two together? This is the whole point of rationalizing, because that would be the 4th root of y to the 4th, which is y. It's okay. Peyton?
I think the new denominator would be 3y squared, right?
Correct. Because look, this becomes a y times 3. And in our numerator, 4th root of x y cubed. Dylan?
Can you go back one problem, please?
Hold on. Everybody okay with here? Okay, we're going back one problem. Go. You're good?
Yeah, some of the numbers aren't printed in this one.
Yeah, you just got to write them in. Okay, now this one looks different. It's not just in the denominator, it's just not a term, something times something. It's the square root of 5 plus 2. Now's when you rationalize the denominator by multiplying by the conjugate. I mentioned the conjugate a few problems ago. I'm going to multiply the numerator and denominator times what? Anybody remember? Jessica? The square root of 5 minus 2. And you're going, how does that help me? Well, let me show you. Let's do the denominator first. Look up here. Here we go. Guys, what's the square root of 5 times the square root of 5? And what happens to my outer and inner terms? They cancel. And what's 2 times negative 2? And then in my numerator, I'm going to take that 5 times this binomial, which would give me what? 5 square root 5 minus 10. And then what's 5 minus 4 in the denominator?
1.
So I get 5 square root of 5 minus 10 all over 1. Can I just write it like that, though? So what I do, I rationalize the denominator. How did I rationalize the denominator? By multiplying by the conjugate. Conjugate. Okay, here we go. Take a restroom break. We'll continue on your continue here, where we're going to rationalize the denominator. We're going to multiply by the conjugate. In this case, what would the conjugate be? Emma, what would the conjugate be? What'd you say, hon? It can't be minus. Yeah, the square root of 3 plus the square root of 5. We got to multiply both the numerator and the denominator by that binomial. Okay? Let's go to our denominator first. We probably can do this in our head. Maybe not. Maybe not yet. What's square root of 3 times square root of 3? 3. And what happens to our outer and our inner? And what's the negative square root of 5 times positive square root of 5? Negative 5. So I basically have 3 minus 5 in the denominator, which is negative 2. In our numerator, we got a FOIL. So the first term would be square root 6 plus square root 10 plus 5 square root 3 plus, careful here, 5 square root 5. And I think that's it. I don't think any of those radicals are going to simplify. There are no like terms, so just finish it right there. Questions? Okay, now you do that one. Go. So your denominator, Caden, what'd you get for your denominator?
4x minus y.
Correct. 4x minus y, because 2 squared root of x times 2 squared root of x becomes 4x. Outer and inner cancel, minus y. What's our numerator become then? Anna, what would 3 squared root of x times 2 squared root of x become?
6x minus 3 square root of xy.
Nice. There you are. Boom. Jacob?
Can't you just...
How?
Oh, never mind.
Yeah, it's not. I know well, I don't know what you're thinking.
I was just thinking you can simplify the 6x in the first place.
Yeah, but it's this whole term
Yeah.
divided by it, so you can't. It's okay. All right, imaginary numbers. An imaginary number is some funky number that even when after you square it, it's still a negative value. Which means the I is equal to the square root of negative 1. Okay? So, what's the square root of negative 25? You need to think of it like this. You need to think of it as, okay, and you don't have to do this, but I just want you to understand that. That's negative 1 times 25. Everybody agree with that?
Yeah.
What's the square root of 25?
5.
And what did I just say the square root of negative 1 is? So 5i. Have you done a little bit of imaginary before?
No.
No? Okay, so then on this one, you can't take the square root of 6, but you can take the square root of negative 1. So how about I square root 6? Oh. So this would become 3i square root 3. Yes?
Yeah.
Okay. Okay, now you got it. Product rule for radicals does not hold true. So you can't just say that's the square root of positive 36 until the answer is 6, okay? What's the square root of negative 4? 2i. Okay, let's write that. What's the square root of negative 9? And what's 2i times 3i? 6i squared. What did we say I squared is equal to? Negative 1. So 6 times negative 1, because note again, I squared equals negative 1. That's why when you take the square root, I equals the square root of negative 1. So our answer in this case would be negative 6. So then here would be 5i. Oh, I'm sorry, that's wrong. I square root 5 times I square root 6, which would give me I squared square root 30. I squared is negative 1, negative. And can I break down square root of 30? Nope, so just be negative square root 30. Okay, it's your choice how you want to approach this one. I would break down the square root of 125 first. Isn't 125 25 times 5? And isn't the square root of 25 5 square root 5 times I square root 5? Now be careful here. What's the square root of 5 times the square root of 5? 5 times this I gives me 25. I. Okay? This is the equivalent to the square root of negative 27 over 3, which is the square root of negative 9, which gives me 3i. I know I got a lot of examples in this note, but I just want to make sure we have this down. And we're doing 2 sections today. Complex number is a number that can be written in the form a plus bi, where a is the real and b is real, but it's tagged with an imaginary number. So here we go. If I ask you to perform these indicated operations, look how easy this is. It's a plus in between, not a times. What's 2 plus negative 3, guys? Negative 1. And what's 3i plus 5i? 8i. Okay, so you're going, okay, that's simple. Got it? So when you subtract, make sure you do what? Make sure you do what with that negative? Distribute that negative through. So it becomes plus, and then plus positive there. So then be careful. Make sure you grab it correctly. What's negative 7 plus 2? Negative 5. What's 5i plus 8i plus 13i? Okay, we'll skip that one. Okay, look at this one. Be smart. That becomes negative 20 I squared, but wait a minute, what's I squared? Negative 1, so negative 1 times negative 20 gives me positive 20. Okay, that's easy, right? Let's keep it going. You here, you just distribute. So 4i times negative 2 would be negative 8i, but plus 4i times 6i gives me 24i squared. So negative 24 minus 8i. Notice how I wrote the real before the imaginary. Everybody foil that one. Go. So this actually becomes positive 27 plus 16, which would give me what? 43 minus 1824 would be 42. Anybody else get that? What did I do? Oh, I mess up? Where did I mess up at? Oh, yeah, that should be. Why did I put negative? Thank you. So we need to erase that and make that positive 6i. Thank you, guys. Awesome. We're almost there, I promise. We're almost there. All right, here we go. We'll go through a couple of these. So when we say this one's squared, let's see if we can do it quickly, and then we'll move on. What's 4 squared? 16. And then the two middle terms times 2 would be negative 24i. And then be careful here. Negative 3i times negative 3i would be positive 9i squared. But I squared is negative 1. So it's negative 9. 16 minus 9 would be 7 minus 24i. Okay, just like you can't have radicals in the denominator, you can't have imaginary numbers in the denominator. So we're going to multiply by the conjugate, which the conjugate of this denominator would be what, Casey?
1 plus I.
Nice. 1 plus I. So we're multiplying both top and bottom by 1 plus I, and I'm going to let you go. Do the denominator first. Always makes life easier. Can you do it in your head? Look up here. Let me help you out. What's 1 times 1? 1. What about the outer and inner? Who cares? And what's negative I times negative I? Negative I squared, which becomes positive 1. So you have 1 plus 1, which is what? 2. Was that too much to do in your head? That's fine. You write it out. But I imagine most of you can write, okay, minus I squared minus a negative 1 plus 1. Got it. And then our numerator is going to become, Jake, what do you get for your numerator? 1 plus 3. Oh, here, let me work it out. So I get 2 plus I, 2i plus I would be plus 3i plus I squared. Nice. So I squared is negative 1. So 2 minus 1, 1 plus 3i all over 2. I think your answer book, your book sometimes is going to write that answer as 1/2 plus 3/2 I. Everybody look up here. They write that as 1/2 plus 3/2 I. I want it written this way. Now be aware of that. So the book's writing it that way. Think about what WebAssign's going to do. They're going to make you write it as 1/2 plus 3/2 I. Okay, so you're going, I'm doing it, what am I doing wrong? I'm doing nothing wrong. Just type it in the way they want it to be written in. Taylor?
Do you want it like in the AXBI form, or like if we put the imaginary number first?
I do prefer the real before the imaginary. I do prefer it. Would I count off for it? I doubt it. Unless you make me angry or something like that, Taylor, for just being a bad kid. Then possibly. Okay? Go to 32. All you need to do to multiply both top and bottom is what? Just Arav?
Just -3y.
Not even, nope, not even a conjugate. Go ahead, redeem yourself. Nope, even easier. Just what, guys? I. Just I. You're not wrong by doing 3i, you're just going to be simplifying more than you have to. So in your numerator, you get 7i. And what's your denominator going to become? -3. So I get -7i over 3. It's positive or negative is negative. Okay? Okay, last part. Here we go. What's I squared? Okay, write it. What's I cubed? No. Look, isn't I cubed I times I squared? Would you agree with that? Okay. And I's I. And what's I squared? -1. So it would equal, what's I cubed, guys? Negative I. So what do you think I to the 4th is? Seth? 1. Because isn't I to the 4th, let's think of it this way. Isn't it I squared times I squared? And isn't that -1 times -1, which equals 1? So can you have that memorized? I, -1, negative I. Okay? What side of the 5th? What side of the 6th? What side of the 7th? What side of the 8th? See, it'll be the pattern. So what side of the 9th? I. What's I to the 10th? I to the 11th. Okay. So what's I to the 16th? Remainder 4, 1. Back up. Say you don't want to count it through. How many? Divide 9 by 4. So how many 4s? 9, 2. What's your remainder? So what's your answer? I. Because the first, so if I back up to this paper, this page again, and I'll write them in. What was this one? 1, negative I. Oh, I'm sorry, that's not 1. That's -1. Negative I and 1. Look up here. Remainder 1, remainder 2, remainder 3. No remainder. Remainder 1, 2, 3, no remainder. When I'm saying remainder of, when you divide it by 4, what's 9 divided by 4? 2, remainder 1. So what's the answer again? I. I'm going to back up to it. Maybe. I'm going to write it down. I. Go to this one. Take 16 divided by 4. What's the remainder? There isn't one. So what's your answer? 1. Go to this one. Okay, first of all, what do you do when you raise anything to a negative exponent? Put it in the, so it's 1 over I to the 20. Can I change that to a -25? So negative, well, now it'd be positive 25, yes? So take 25 and divide it by 4. What would your remainder be?
Wait, where'd you get the 24?
I changed it.
Oh.
I changed it.
Oh, okay.
I don't want to have a remainder of 0. I changed it. So I'm going to, everybody good with the first step. 1 over I to the 25th. Divide it by 4. Remainder what? 1. So it would be 1 over I. I'm not okay with an imaginary number in the denominator. Rationalize it by multiplying both top and bottom by. So now it gives me I over -1, so I. Ooh. We'll do schedules